Next up is Mr. Abdelrahman from the city of Tallinn, and he's going to tell us about the 3D models and the digital twins that has been building for the city of Tallinn, continuous work there, including subsurface layers and lots of interesting stuff that he's going to tell us. Please.
Yep. Thanks. Hello, everyone. My name is Abdelrahman. I'm 3D specialist in Tallinn Strategic Management Office in Tallinn City, and today I'll be talking about 3D as well. And I'm glad actually that my colleagues already spoke about 3D stuff, so the brains are already warmed up and ready to think in a 3D dimensional way. So I'm going to talk about it in a story way. So basically, imagine that we have a timeline of our 3D products. How do we develop them along the time using Esri products and other products as well? So I'll be covering 3 stops along this timeline, which we would like to highlight them today. And I would like to start from the very beginning, from the basic thing that we started with, which was Tallinn 3D model. It's an open or like a public website where everybody can find it. And the first idea was to have a platform where we can have a beautiful representation or a beautiful visualization of the 3D data that we were having, and as well as support urban planners and architects to have their platform to visualize perhaps their projects with a better sense of spatial data. This is our website in here. I don't know if yeah, okay. Anyway, we don't have to navigate through it, but it has kind of basic functions in the beginning. You can see how the shadow differs along the time from one day to another, or from one season to another. You can measure distances and spaces between buildings or even in empty spaces, and some other functions. In this project, or this is obviously a Esri web app, where we use all the 3D data that we are having. We store them in Esri servers, and from there we start basically applying those layers or taking those layers to the web platform. I'm going to speak briefly about the type of 3D data that we are having in this platform. So we start with the highest level of detail in the model, which is covering Tallinn city center, particularly the old town. Those models are all manually created, so you can see that they're as accurate as possible. They are looking much more beautiful than others, and as well, after modeling them, we kind of geolocate them and add our semantic data. And then we have point clouds, are covered and updated annually by Estonian Land Board, and we use them mostly for, in that model, we use them mostly for the ground elevation, as well as the shape of the roofs of other buildings, not the manually created ones, but the automatically generated ones, which is the third type of data that we're having, LOD1 and LOD2, and those are basically covering the entire Tallinn city apart from the old town. And then we have 3D scanned data, or like photogrammetric meshes, which are used internally for some maybe smaller pilot areas where any stakeholder would like to test their, I don't know, prospective projects or change that might happen in a specific area in a more accurate shape of the models, basically. And then, of course, we have BIM models used for the same purpose internally, and all of these data that I spoke about are saved or stored in our Esri servers, and then we take them to the web platform based on the needs, and according to the need we choose which data that we want to use. So that was the first stop, the 3D model of the city of Tallinn, or the web app of city of Tallinn, where we have our 3D platform. And then I'm going to speak about the next stop in the timeline, which was a project called Green Twins. And it's a collaboration between Tallinn City, Helsinki City, Aalto University in Helsinki, Baltic, Tallinn University of Technology, and Finnish Center of Smart Cities. It was funded by European Union, and the purpose of having this project was more precisely concerned or focused on vegetation and greenery areas in both cities. As you might know, Tallinn last year was the European Green Capital, so keeping the greenery areas, trying to improve whatever surroundings around them is one of our main priorities. And in that project, we had two main concerns. We wanted to improve the quality of the digital information that we're having about the green areas, as well as develop a smart way or a smart participatory urban planning platforms. And we worked on two things. First of all, develop a digital library of the plants, and we wanted to make it as dynamic as possible so that it can kind of simulate how nature changes. And second thing was to create user-friendly physical spaces and as well, user-friendly physical and virtual spaces where we can show, for example, the digital plant library or other products. And we have reached to three main achievements in this project. I'm going to cover only two of them just for saving your time. So I'm going to talk about the digital plant library and physical space. Digital plant library, as explained earlier, is a library of 3D models of trees that are chosen from both cities, the most common species, basically. What makes this digital plant library unique is that it's not only a 3D model of a tree, but it's a dynamic 3D model of a tree. What does that mean? It means that the model itself is smart enough to change based on the data that you enter, whether it's, I don't know, one tree after 10 years, how would it look? In which season, how will it change? And here you can see, basically we start from a small 3D model of the twig, of a twig or a branch, and then there is an algorithm. The algorithm takes in consideration the branch elongation, how many new branches are generated in each tree, how does the gravity affect the bending of each tree species, and also the branch death rate, how does it happen for each species. And this data is entered by trees experts or like vegetation experts, and then the algorithm generates automatically a tree out of the twig that is manually modeled. You can see down here we have different level of details per each tree, and in here this is an example of how the dynamic plant library works. So we only model one branch, and then the algorithm generates trees based on this, how they grow in the age, how they change in the seasons, and the level of details, how does it change as well. And this is, as I explained earlier, this is the beginning, basically just a branch model. And here is an example of how those trees look like. Basically, if you zoom into them, it might not be as clear in here, but if you're having your 3D viewer and you know a bit about trees, you can tell by just looking at them which species it is. So it was as detailed as possible, as light as possible in a 3D model size-wise. So you can use perhaps, I think, 1,000 model in one scene. It will not be too big for your project. Now coming back to our 3D model, the first stop. How did we utilize those trees that we just generated in our model? Now this QR code takes you to the 3D model of Tallinn City. It's, as I explained, it's public. You can navigate around Tallinn city and see what I'm talking about. And in here, as I explained earlier, most of the layers are adjusted in ArcPro. And then we upload them to ArcGIS web apps. Sometimes we use the data interoperability tools in order to change the types of some 3D files in order to have them all compatible with the web app requirements. So this is about the public one. And then internally, we have another version of our city model. Okay, yeah. We have another model of our another version of our city model where we are testing 2 new layers. We have traffic signs, we have vegetation, where we use those trees that we just generated. We have a point layers, one points layer in ArcGIS, and we use symbology in order to kind of simulate how those trees look like. So this is just a quick tour around our city model. You can see, as I explained earlier, Old Town is in the highest level of details. And now we're coming to an area where we tested how those trees will look like. So we have the trees data, the speed, the size of the tree, the height and everything. And that's how they would look like. And our aim in the future is to have this layer expanded all around the city based on the data we collect. So now what's next? We go to Avalin, which is a physical space hub that was created again after Green Twins project. And basically the purpose of this hub is to have a participatory physical space where people can gather, perhaps make workshops, test new softwares and test new scenes, and see how would they look like. So this is a quick video. Just
is already a part of our everyday work. It is quite evident that we need different tools to engage different stakeholder groups. The Avalin Participation Hub is a co-creation space designed for city officials, the citizens of Tallinn and experts. It is meant to feel like a living room. It is equipped both with digital tools as well as old-fashioned ones to engage all stakeholder groups. And it's designed for workshops, discussions and events that should happen before arguments arise.
As my colleague explained earlier, it's equipped with advanced 3D tools. So basically we have one of the best 3D projectors, and we have joysticks and VR glasses. And now we move to the third and last step is, what are we going to do with this physical space? We wanted to kind of enrich it with a good content that fits with it. And from there, we thought of creating VR simulations. So we have a city model already, but we want to make it more interactive. How would we allow citizens, stakeholders who would come to our Avalin or city hub to interact with this data that we are having? Of course, there are a lot of benefits of using VR simulations. I'll not go through all of them in details, but yeah, you guys can find them here. And one of the most important things is the interaction level. It's different than just having a 3D platform where you can navigate, but you can actually, in VR or in game engines, you can more interact with the data. You can have a more realistic feeling of different scenarios. And for that, we thought, why don't we use, for example, a game engine like Unreal, which is one of the top game engines. And how do we use it? How we utilize our data stored in Esri servers? We find that Esri has created a plugin for Unreal. And this plugin basically allows you to sync your online saved data into Unreal. So you don't have to download the 3D models, for example, or ground elevations on your computer. However, you can just online sync them inside Unreal. That's how it looks like. So basically, on the top left, you can see the plugin menu where you can choose base maps from Esri. You can collect layers, sync them, and that's how it would look in real life. There is a next and last video. I'm going to share it, and it's basically enhancing the idea of us wanting to do a VR simulation. For example, in the next video, I'll be showing one perspective project. It's planned to be happening within, I think, the next 2 years, or to start working on it. And how would VR make it easier for people to imagine those projects to get a more a better spatial sense feeling of how an area would look like after a bigger change.
The city of Tallinn is using VR technology to shape its future. With our new VR simulation project, we're revolutionizing urban planning and citizen engagement. Today, Tallinn unveiled a new vision for the area surrounding Linnahall, sparking discussions about its future. This project aims to initiate a dialogue among citizens, stakeholders, and city planners about the area's potential. Through immersive VR experiences, stakeholders can explore proposed designs, provide feedback, and actively shape the city's development. Whether it's the reconstruction of Linnahall or new construction, the VR simulation project provides a platform for exploring various options. By involving citizens from the outset, Tallinn ensures that development decisions reflect the needs of its people. This approach sets a new standard for urban planning, empowering stakeholders to shape the future of their city.
Yep. Basically, that was it. Thank you very much for listening. And if you have any questions, please let me know.
Thank you. That's really interesting work. And I believe there's a question from the Slido.
Yes, thank you very much. Actually, there is 2 friendly questions. First one, how frequently and from which sources you are updating your 3D? That was partially answered from the slides, but can you repeat some?
Mm-hmm. Yeah, sure. Basically, there are some updates that happen quite frequently, almost on a weekly basis, which are related to the base map. And this is done through Python script. So whenever our cartographers or people who works on the maps and base maps, they make any change, this is going to be updated as quick as possible on a weekly basis. And then we are trying our best to keep it entirely updated every year. So every year we make sure that the 3D buildings and models themselves are updated, and this, of course, requires some manual work.
Yeah, thank you. And another one is a little bit funny. So do you know any departments in Tallinn who is not using the ArcGIS yet, or GIS systems?
No, honestly, I don't know who's using it.
Okay.
Yeah.
Good. Okay, thank you. Thank you very much.
Thanks.
That's all about questions.